So today we're going to spend some time talking about estimation. Estimation is basically just sort of a guess at how close you are to a value when you don't need to know the exact value. The reason why I like estimations because if I'm shopping, getting groceries or in Walmart or something, and you buy something and you're looking at, okay, well, how much the tax is going to be on this? Well, 15%. You can kind of get an estimation going on there of how much taxes you'd be actually spending, so you can kind of get an idea of how much you'd actually be paying at the checkout before you got there. I had the interesting, I should say the unfortunate incident where one day I was at Shoppers. It's a true story. Shoppers Drug Mart. I was getting checked out, and the cashier checked me out, and she gave me the bag with all the stuff in it, and I was like, "Excuse me," I said, "No, you must have something wrong because I was doing the estimation thing in my head." And I said, "Like, you didn't charge me enough money. You must have didn't bring something in or something, whatever." She's like, "No, it's fine, it's good." I said, "Well, it should have been at least this much." And she's like, "Yeah, but I just gave you the senior's discount." I was like, "What?" I was like, "Oh, what do you think I am? I'm not a senior yet." She's like, "Oh my God, I'm so sorry." So she gave me the discount anyway. I was like, "Okay, I meant to note." Okay. So anyway, too funny. So let's talk about estimation. So they use estimation. They say estimation is a method of coming up with a math answer that is general, not specific. So if you don't even know the exact answer, the estimation is fine. Like we talked about a minute ago, if you're trying to determine taxes, things like that, sales tax or whatever. And the easy way to do sales tax, I find, is like 10% is easy. So if you're buying something that's like $100, take 10%. So it's $10. Then half it again, add it together. So it's easy way to do it 15%. So do 10 and do 5, and it's an easy estimation. So it says, for example, with money, rounding is done to the nearest dollar, and if the amount is 50 cents or more, round to the nearest dollar, and then then drop the cent amount. So basically, it's sort of like using rounding, but in an estimation form. So they give some examples in here. And they said March, the actual expense was $65.85, and the estimated expense was $66. So it's just rounding off thing, basically, this kind of thing. October, 59.10, and they said just 59. Then what they did here, they used two numbers right here. And we were to add those numbers together, it would look like this. $66. $125, and they say down here 125 this is the actual amount. It's not an estimation; it's an actual value. So let's look at some of these for practice. That's weird noise. So I looked at the first one, number 1A. If I want to just get an estimate, what I could easily do, instead of using 72.9, so let's look at number 1A. Instead of using 72.9, I can just use 73 plus, then I could say plus 15 then I can say plus 121 then I can add those together, and you can see it's going to be 75 and 15 gives me 88, and 121 is going to give me 209. And that's not an exact value because I estimated it to the dollar value under those first three numbers. So it's basically just an estimation. Are we cool with that? I'm not going to spend a lot of time on estimation because its value for mathematical purposes not really great, but it's just there for kind of like help you in a pinch if you want just an approximate value of what you're doing. The next piece here that I will spend some time on is this one here. So, stats can get very involved. I know because I've done some advanced stats courses. I've done two years of two semesters of stats in university. So it can get pretty crazy when you get into some values. But we're not going to get that crazy with it. We're just going to talk about mostly just very basic stats, stuff like mean and average. So it says here, the arithmetic mean is also the average. So when you hear something say like in the stats and use the word mean right here, it just simply means the average. And to get the average, basically take the numbers you have, add them all together, and divide by the number of numbers that you have. So, compute the mean or average. Again, just add the units of measure and divide by the total number of units. And if you notice, one of the questions on the assignment that I did, should have showed you earlier today, was I showed there's a question in there about averages, and this one comes from this part of the chapter right here. All right, so let's have a look at the mean. So it says here, use addition and division to find the averages of the following word problems. So Deb needs to purchase new calendars for examination rooms. This is kind of almost exactly like the one in your assignment. If the average of the calendars costs 11, 7, 10, 5, 10, 12, 8, and 9, what's the average? So all we have to do is take those numbers and add them all together. So you can see, adding them all together, I have 11 plus 7 plus 10 plus 8 11, 7, 10, 5. Sorry, that's 5. Plus 10 plus 12 plus 8 plus 9. So the numbers I have 8 of them, 8 numbers. So if I would add them all up, the most difficult part about doing this is making sure you don't miss a number. Alright, if you miss a number or write it down twice, then you're going to get messed up. So be careful with that. What you could even do, you could even just, as you write them down, cross them off, 7, 11, cross them off, just so you don't miss nothing. And then the second worst thing about it, even though you're using a calculator, or I said you could use a calculator, making sure you put them in there properly. And don't forget one going in. So putting them in there looks like this: 11 plus 7 plus 10 plus 5 plus 10 plus 12 plus 8 plus 9, and the total is 72. So over here, this will put a 72. I have 8 numbers in total, so to get my average, or I should say the mean, will be 72 divided by 8. And this is acting really weird. I think it's getting hot while it's slowing down. That's not plus, it's divided by. In your calculator, you just go divide by 8. Actually, in this calculator, there's a trick you can use. You can just go take this second function answer, and the answer is 9. So 9 would be the mean, or the average score for each of those calendars. Are we cool with that? That's not too bad because we're used to doing averages pretty much. You know, test your average test scores, average assignment scores, add them all together, divide by the number you have. It's pretty basic. So I'm not going to spend a lot of time with that one. What I'm going to do is the next piece. Median is a little different. The median is the middle number. Now, it's not just the middle number, that'd be too easy, right? What it is the middle number once the numbers have been rearranged from smallest to largest. So the median is literally the middle measure when it's arranged from smallest to largest. So if you get a bunch of numbers like down here, they show you a bunch of numbers. 23, 54, 76, 34, 12. You have to take those and rearrange them or sort them from smallest to the largest. Once you sort from smallest to the largest, the median is the one in the middle. Make sense? Not too bad. There is one problem though. The problem that comes in is right here. Oh, come on. This page here worked out great, because you know why? Because we have an odd number of questions. Sorry, an odd number of numbers. What I mean by that? We have 1, 2, 3, 4, 5 numbers. We have 5 numbers. It's quite easy to find one in the middle. Because one in the middle right here, 34. There's 2 on both sides. So it's easy to find the median at 34. Yay, nailed it. However, what happens when we don't have an odd number of numbers? We have an even number of numbers. That gets a little more tricky. So notice right here we have numbers we have are even. So I have 1, 2, 3, 4, 5, 6. But it's not too bad again, because what we do, we rearrange them again from smallest to largest. So right here, rearrange them from smallest to largest. Am I seeing anything wrong with this question? Am I seeing anything wrong with that? This is your textbook now, right? I want to pause for a second and look at it. And I just mentioned the problem a minute ago. See if you can find the problem with that. This is to show you that sometimes your textbooks are not perfect either. And sometimes your textbooks contain mistakes. And this one's not bad. And I never caught this mistake last time, but it's there this time. And this does have a couple of mistakes as well that I have found before. But what's wrong with this question? Anyone see it?
Odd numbers.
Well, last one was odd numbers, right? We had 5 numbers, right? 1, 2, 3, 4, 5. This one here, there's even numbers, 1, 2, 3, 1, 2, 3, 4, 5, 6, right? They missed a number, right? Because it's supposed to be based on the first one, but we'll write it all down. Looks like this: 12,
36.
missed 36, yep, plus 23. Sorry, not plus. Just gonna write them all down first. 12, 23. 34, 36, 54, and 76. Now they said cross numbers from each end till the last pair is reached. Well, that's fine. Let's do that. That works fine. But we may do this one here. Last one gone, that one gone, that one gone, that one gone. The last pair reached is right here, but it's not, but the picture shows you right there. So if I didn't point this out, you may be wondering where this came from, because 36 is missing in the picture. So what they're trying to get you to realize To get the median, we actually take these two numbers here, the ones that are now in the middle, are supposed to be in the middle. We add them together, so we go 34 plus 36. That gives us 70. And we divide that by 2. That's where it comes from in the example. And that's the median. So if there's an odd number of questions, if there's an odd number of numbers, line them up from smallest to largest, take the one in the middle. If there's an even number of numbers, line them up from smallest to largest, and take the average of the two in the middle. That's how you do it. So I'm glad I picked up on that, because that would throw you for a loop if you're trying to do your homework and reading the book and it's like, that doesn't make sense. Well, there's a mistake in the book.
Even in the second one, 34 and 54, there's no 36, and you talked about two.
Yeah. There's no 36 in, there's no 36 in, yeah, there's no 36 in either one of these. Right?
Yeah. Because you tell last pair of streets, you got 12, 20, 30.
Yeah, so if you're reading closely, you say, where'd that 36 come from down there?
Yeah. And like the 34 is not scratched out, but you have 54 and 76 scratched out.
Yeah. Strange. Alright, so at least we know what that's all about. So let's just look at the, I think there's one more piece in there that I want to get through today. And it's probably called mode. I'll do mode, and then we'll probably do some examples of each one of these three. The mode is probably something you never dealt before. Matter of fact, the median may not be something you're familiar with either. The mode, simply put, the mode is the most frequently occurring number. So, the mode is the most popular, or about, I prefer to say, the most frequently occurring number. So if we look down here, Bob's caloric intake of snacks per day, they said right here, is 120, 120, 50, 78, 134, and so on. And then Sunday, the same thing. But you'll notice if you start counting them up, you'll notice that 120 occurs here, 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 and here. And it's the most frequently occurring number of all the numbers that are there. So then 120 is the mode, most frequently occurring number. There are times when you can have two numbers that occur at the same frequency. For example, if we had, let's see, let's say we have 125 three more times, then 120 and 125 would be two modes, and it would be referred to as bimodal.
Mode is the most popular.
Sorry?
Mode is the most popular.
Yeah, most popular, or a number that occurs the most frequently. Whoa, the ghost in the machine today. I don't know why it's behaving so slowly. One more value, something called a range. So the range is a set of numbers, the range of a set of numbers is the largest value in the set minus the smallest value in the set. So the example that they give here, these examples of 6, 9, 10, 8, 7, and 5. So what you have to do when you find the range, look for the smallest number and the largest number. So right here you see the smallest number is 5 and the largest number is 10. So subtracting the smallest number from the largest number, the range is 5. So these are not hard calculations, just getting them confused, maybe keeping them organized straight in your head, maybe the hardest part. So the range would be the smallest number subtracted from the largest number. Not to be confused with the median, which is line them up in order, take the one in the middle. So you see there's similarities there a little bit, but they're very different. They're different sets of data.
So like range would be like, say like 5 to 10 miles. Base range like 5 miles.
Yeah.
So median is the middle.
Median is the middle.
Mode is the most popular.
Always most popular.
And range is based on smallest degrees.
Yeah. And then there's the mean, which is the average. So let's do some examples. Let's do number 5. I'm not going to go to Roman numerals today. We'll leave it till Thursday. So Beth was working hard to increase the amount of fruit and vegetables in her diet. She kept logs of servings. Monday she has 8, Tuesday she had 7, Wednesday 6, Thursday 5, Friday 8, Saturday 6, Sunday 9. What's the mean daily intake of fruits and vegetables for Beth? So first thing we do is I write them all down. This time, did it need to be in order or not this time? Did it need to be increasing?
I'm going to say yes. I'm going to say no.
What's your final answer? Final answer is these ones do not need to be in increasing order. Because all we're going to do is add them up, divide by how many we have. So for mean, they do not need to be in increasing order for mean. So we're going to have 8 plus 7. So 8 plus 7 plus 6 plus 5 plus 8 plus 6 plus 9 Alright, so I want to change this up a bit on you guys. Make a whole new set of questions from this one question. What's the mean here? How do you know? That was pretty fast. Well, to get the mean, you have to add them all up, right? So it's going to be 8 plus 7 plus 6 plus 5 plus 8 plus 6 plus 9. 49. And we have 1, 2, 3, 4, 5, 6, 7. So the mean would be 49. 49 divided by 7, which is 7. And if you're really doing some statistics, the mean is represented by an x with a bar on top of his head. That's the symbol for mean. And if you're doing the real stats work, that's what the symbol for mean is. X bar. So the mean is actually 7.
So if we're talking like, let's just say like Statistics Canada, like means of like the average amount of people.
Yeah.
Okay.
Yeah.
So you just put the X for that amount, right?
This is the symbol for mean.
Okay.
So that's the mean. What's the median? All right. So to get them, remember how we get the median? How do we get the median? You line them up, right? Smallest and largest. 5, 6, 6, 7, 8, 8, 9. 1, 2, 3, 4, 5, 6, 7. So the median would be the middle number. Also 7. Okay. Just using the same data set here. What would the mode be? What would the mode be?
Mode would be 5. Small number.
Okay. Remember what the definition for mode? It would be what? Most.
Most.
Yeah.
That'd be
8 or 6
6 is 1. Is there another one possible?
or 8.
So we have 2 modes in this case, and therefore it's called bimodal. Okay. Now, what's the range? So the smallest would be 5.
5 to 9.
Largest. Largest is 9. So the range would be what? Sorry.
4.
Range is 4.
Okay.
It's the largest one minus the smallest one. That gives you the range.
Okay.
So even though the question didn't actually ask for it, we did all 4 data measuring points. We did mean, median, mode, range from the same single data set. And that comes down for every piece of data set you find. We can do the same thing for every one of them. Sound cool? All right, it is 20 after. We are done.